Hey, you're dead! It's good to see you guys. Atia, can I ask, what are Jimborinos? Jimboronies? I'm not entirely sure. I don't know what a Jomborini is, or Jimborini, but whatever it is, it's awesome. Jomborini is pronounced like macaronis, by the way. Okay. Jimboronies, macaronis, sure. Cool, right, so guys, we're doing really well. Register's going well. I've got Amani, I've got Lara, I've got Atia, got Ananya, got Dom. How we doing? Got Atia, yeah, we're smashing this, doing well. There's Zach, yo, Zach, yo, Lynn. Yo, how's it going, guys? I'm just filling in the register. Zach is here. There's Lynn. Yeah, got Lynn. Whoop, whoop. We're doing well. Ha Sophia's in. Boom. Smashing this today, guys. Smashing it. Still waiting for a couple of people. How Ping? Yo. Sup, dude? What's up? I'll add that into the register. Where's How Ping? How are we? There we are. Smashing this. Yeah. You're frozen. I can't hear or see anything. Oh no. Has it stopped already? Oh no. Oh no. Pause. Has it fixed itself? I definitely need Ananya. Has it unfrozen? My laptop has been struggling a lot recently, but I'm getting a new one today. So I'm very excited. No more of this glitchy problems that I've been having. Oh, come on, guys. Someone give me a heads up. How are we doing? Is it still working? Audra's in. Yes, there's Audra. Let's get Audra in there. There we go. Yes. How's it looking? Is it working? Ananya, give me a heads up. Hi, Miss Duncan. Hey, Kayla's in. Libby's in. Oh, we're smashing this. Kayla's in. Libby's in. Yes. Just looking for Tiffany, Mel, Caitlin, Ryan. There's Tiffany. Ha-ha. Yes. We've nearly got a full house. Come on. Come on. Wait, Mr. Duncan, how will you get a new one if none of the stores are open? Mel's in. Boom. There's Mel. Ha-ha. Yeah, just waiting now on Caitlin and Ryan. I'll start the lesson now, guys. Hey, everybody. Thanks for coming along. It's great to see you all. So today, guys, I'm going to be quickly going through the worksheet. Oh, by the way, question on the laptop. I ordered it on Lazada. We will see. Caitlin's in. There's Caitlin. Oh, we've nearly got a full house. Come on, Ryan. Where's Ryan? Ryan's the only one left. Where are you, Ryan? Oh man. Okay, so I'm gonna get cracking. So I'm gonna share my screen. Yeah. Share. There we go. Get that onto that bit. There we go. And then I'm gonna crack on with this bab. Okay, cool. So let's get rid of keyboard. John. There we go. Right. Okay, so last lesson I set you guys a little bit of homework. Ooh, I'm trying to set my laptop up, trying to keep it cool. There we go. So I'm hoping that it is all still working. I'll get him. Nice one, Dom. Ryan's coming, he's on his way. Gonna have a full house. This is very exciting, this. Okay, so I set you guys a couple of bits of homework, 2 sets of equations to be doing. So I'm just gonna go through those answers now. I'll try and be as quick as I can. So metal plus acid, salt and hydrogen. So 1 magnesium. Oh, whoa, that's a thick pen. Let's scale that down a bit. 1 magnesium. There we go. 1 magnesium, 1 magnesium, 1 hydrogen, 2 hydrogens. Double it. Okay, next. So I've changed somebody. Start again. 1 magnesium, 1 magnesium, 2 hydrogen, 2 hydrogen, 2 chlorine, chlorine. Done. Next. So this is swap the metal, guys. Swap the metal or swap the non-metal, whichever way round you want to do it. No worries. Yeah, so I'm going to form sodium chloride and copper hydroxide. So 1 copper, 1 copper, 2 chlorines. 2 chlorines, 2 sodiums, 2 sodiums, 2 oxygens, 2 oxygens, 2 hydrogens, 2 yes, done, smashed it, tick. Next, phosphorus, speaking phosphorus trichloride. Oh, that's clever. Element, diatomic, 2 and 3, common denominator, get it to 6. There you go. And then check your phosphoruses. Should work out. 2 phosphorus, 2 phosphorus, 2 phosphorus, 6 chlorines, 6 chlorines. We're good. Tick it if you got it right, folks. Next, PaCl3 plus water. Oh, that's a tricky one, that. Forming phosphorus hydroxide. Ugh. Cool. Oh, Ryan's here. Yo, Ryan. Go on, Ryan. Give us a shout out on the chat. I'm loving this on the chat thing. It's amazing. So we've got 1 phosphorus, 3 chlorines, 1. Okay, let's do that. Let's make it nice and easy. So, okay, then 3 chlorines, 3 chlorines. Okay, phosphorus is 1 and 1 still. Hydrogens, 2, 3. Common denominator, 6. So if I do that and then that, right, that'll make the hydrogens add up. Yeah, oxygens, oxygens don't add up, though. Oh, that's interesting. Oh, no, hydrogens don't add up. Oh, that's not good. Hang on a sec. That's a bit more tricky, that one. The reason being is because you've got 2 hydrogens here, but then you've got 4 over there. Let's do the oxygens. Well, do you know what? Let's just double it. Oh, do you know what? I'm going to do this old school. I'm going to draw that there. So, and that one over here like that. 2 of those. There we go. So we've got 1 phosphorus, 3 chlorines, 3 chlorines, 4 hydrogens. Oh, well, I've got 3 and 3. I've got 6. So let's add another one. Let's add another one to that side. Yeah, let's do that. Next, so phosphorus 1, chlorines 3, hydrogens 6, 3 and 6, oxygens 3 and 3. We're golden. Look at that. Yeah, that's a much harder equation to balance. That becomes a 3 there and a 3 there. Winner. Good. It's nice to go old school every now and again. It just, honestly, sometimes it just makes it that little bit easier. Let's have a look. Oh, do we have to say trichloride? Do you have to write trichloride? Yeah, I think so. So we think you're wrong in write phosphorus chloride. Lara, okay, you've asked a really good question. And the reason why you have to call it phosphorus trichloride is because it's simple covalent, Lara. It's like carbon dioxide. It's because it's a covalent compound. You tend to give the actual number. Like water's real name is dihydrogen oxide in reality. So because it's covalent, you could have said phosphorus 3 chloride if you'd liked, but that would suggest that this would be phosphorus Roman numeral 3 chloride. But that would suggest it was an ionic and also transition metal. But yeah, so we tend to say phosphorus trichloride rather than phosphorus 3 chloride. But great question, though. Great question. Yes, there is phosphorus pentachloride as well. Yes, because there's such a thing as phosphorus. Yes. Tiffany, yes. Absolutely. Next one. Oh, propane. It's nice to see propane up. It's a combustion. Oh, it's a complete combustion. How do I know it's a complete combustion, year 10s? We did the combustion stuff, didn't we? Let's just check previous lesson. We covered the combustion stuff in last lesson. Yeah, we did the kind of equations with it. And we talked about complete versus incomplete. Wow, my writing got like super big. Oh, wow. Yeah, so what type of CO2? Well done, tells us. Well done. Great job, year 10s. I'm so proud of you guys. I'm so proud. So we've got complete combustion of propane. Let's balance it. 3 carbons, 8 hydrogens, 2 oxygens. 6, 4, 10, 5. I'm done. Winner. Winner, winner, chicken dinner. Amazing. Right. Now it gets a bit more difficult because now we're going from word to symbol. That's a bit more challenging now, folks. Definitely. So we're going to go from... Oh, that's amazing. Okay, so we've got copper solid, Cu. It's nice to have the state symbol there too. Plus oxygen, O2, gas. Going to form. Ooh, By the way, there's an incorrect question there. You see, the internet is full of really good resources, but not always good. That there is the incorrect name. It should have been copper Roman numeral 2 oxide. The reason being is there is a copper 1 oxide, but copper 2 should just be CuO. Balance it, 2 coppers, 2 coppers, 2 oxygens, 2 oxygens. Tick it if you've got it. Add the state symbol as well. Well, you know, why not? Do you have to put the state symbols? No, I don't really care about the state symbols. The states are there. It's nice for you to practice using them, but not really such a big deal. I'm much, in this exercise helping, I'm much more looking to see how you guys are coping with the translation into symbol from Word. That's really the goal here. Potassium solid, K. I'm gonna use my state symbols, plus H2O liquid, one of the rare liquids of the world. And then we go potassium hydroxide, KOH, and that is the correct formulae. The reason being is K is +1, OH is 1 minus, crossing down, we're done, it's aqueous, I like that, and hydrogen gas. Let's now balance. 1 potassium, 1 potassium, two hydrogens, 3. Ooh, that's nasty. So add another one there. That's going to take us to 4. Oh, that's nasty. Then I do that. I'll take us to 4 too. And then we're going to need 2 of those, and then it balances. There we go. Not easy that though, folks. Again, tricky one. Group 1 metals with water. You have to know those as well. They're super common. Next, aluminium oxide. Ooh, got to build the formula. Al3 plus, O2 minus, crossing down at Al2O3 solid plus nitric acid, H plus NO3 minus, crossing down HNO3, going to aluminium nitrate, Al3 plus, NO3 minus, crossing down, eek, that's tricky, Al brackets, NO3 close brackets 3, plus H2O. Wowzer, what a jump in level. That just went from a level, the first one, you could actually level these. So if I level these, it's nice to do so. The copper oxide one will probably be level 5. This one is definitely going to be a level 7, but this one is definitely level 8, 9 for sure. I've got year 12 students who won't be able to do that, folks, just so you know. So if you're managing those, you are doing great. Let's now balance it. 2 aluminiums. We've got 2 aluminiums. We've got, oh, whoa. Wowzer. Let's just do it the way I was doing it. 2 aluminiums, 1 aluminium, double it. Right, 2 aluminiums, right, oxygens. Right, oxygen, right, I'm gonna do the nitrate bit first. Yeah, the nitrate bit here. I'm gonna treat that as a single one. So I need how many? I need 3 of them there, so that'll need 3 there. Then I'm gonna need hydrogens. There are 3 hydrogens here, but the water has 2 in it. That's tricky, that. Common denominator is 6. So I'm gonna need to put a 3 here, common denominator, take that up to 6 there. Let's clean this up a little bit. Right, now I need to balance the nitrates again. Oh, I'd already done it. Oh, I'd miscounted. There's 3 there, but times 2, there's 6. That adds up now. Oxygens, 3 and 3 aluminiums, that now adds up. Wowzer, that's at least a level 9. That's by the way, that's a grade C at A level, just so you know, folks. Yeah, that's hard. Next, so sodium hydroxide, NaOH, Na plus OH minus, nitric acid, HNO3. So acid plus base plus acid, salt, sodium nitrate, Na plus, NO3 minus, 1 and 1. That makes it easy. And water. Oh, what you notice is it's already balanced. That's nice. Oh, I like that. Why, thank you, chemistry. Oh, sorry. Magnesium solid plus silver nitrate. You got to remember that one, folks, because silver is a +1 ion. Swap the metals, nice and easy. Magnesium, ooh, Mg2 plus, NO3 minus, crossing down, I'm going to need 2 nitrate ions. Yeah, I'm going to need 2 of the nitrate ions. So I need brackets, NO3, close brackets, 2 plus, plus silver. Nice. Hello, Mr. Silver. We're going to need 2 nitrates, going to need 2 silvers, and we're done. Cool. That was a fun game. Next. Magnesium solid, Mg again, plus carbon dioxide. Oh, that's actually a really cool reaction. I've never actually done it myself, but it's cool because magnesium burns in carbon dioxide. Like, that's like, no one else does that. Calcium will do it, but yeah, it's kind of rare that. And it'll actually take the oxygen from the CO2 and turn it into carbon. Bit crazy. MgO plus solid carbon, balance it. 2 oxygens, 2 magnesiums, we're done. Take it if you've got it, folks. I know these are hard. Next one. Oh, this one's just a case of applying what you know. Ammonia is a tricky one. You've just got to learn ammonia. It's so important. Plus oxygen. Right. Oh, oxygen's going to steal the H's, isn't it? It's going to form nitrogen gas and water. It's French for water. And then you just have to balance it. 1 nitrogen, 2 nitrogens. Put a 2 there. Next, 6 hydrogens. 6 hydrogens. I like it. Oxygens, 2. Oxygens, 3. Common denominator. Common denominator for 2 and 3 is going to be 6. So I'm going to put a 3 there. Going to put a 6 here. Yeah, and then now I need to go back and change everything again because my hydrogens are now on 12, which means I'm going to need a 12. Blimey. 4? Whoa, my battery's running low. Oh, hang on, folks. Sorry. I don't know what's going. Oh, I don't know why it's not charging. Oh, that's bad news. I don't know what's going on here, folks. My laptop isn't charging for some reason. Oh, there we go. Seems to be charging now. Don't know quite why it wasn't before. Sorry, back to this. Nitrogens. This is going to be horrible, isn't it? So nitrogen, hydrogens. Oh, hydrogens have got 12. I need to get, so I'm going to get 4 there to give me 12. 4 times 3 is 12. Yes, 12, yeah. And then nitrogens up to 4, so it's a 2. And we're done. That's hard as well. Let's have a look. Oh, do you have to put no? And then, Mr. Duncan, why do you have to memorize silver nitrate? We don't. We need to memorize silver. That's a +1. I think you just have to know that silver is Ag+. Yes, that's correct. Melanie, Tiffany and Laura are correct. The reason being is silver's a bit of a pesky one. The reason why silver's a little bit pesky is because if you actually go to the periodic table, you see that silver is in the transition metal block, which means it should have variable oxidation states, should have various charges, like iron 2+ and iron 3+, but silver doesn't. Silver is just Ag+, which means they will just expect you to know it. Next, right, high difficulty. I don't know why that's high difficulty. Hydrochloric acid plus Mg. That's not very hard. That's going to form right now. Oh, I see why this is hard, folks. Why is this harder? Because you're now not getting given the product. The previous one was just convert from words to symbol and balance. Now we're not going to give you any of the products. We're expecting you to be able to build it. So we've got a metal plus acid, salt and hydrogen. I'm going to get magnesium chloride. That's the correct formula. And hydrogen gas. I'm going to have to balance it and I'm done. Year 10. Oh, I want to check. Does silver also have +2 or something? No, it doesn't. Yeah, Dom, you're absolutely right. It does actually, but it's super, super rare. You never come across it really. Well done, Dom. Yeah, and a +3? It does? Wow. I didn't even know it did +3. Anyway, I don't want you guys to know that. I definitely want you guys to be focusing on knowing that silver is a +1 only. Yeah, so let's just stick with that. You can do state symbols for task 3. Can you? Yeah, of course I can. Hydrochloric acid, of course, is going to be an aqueous. All acids are aqueous, folks. Magnesium is a solid. That one, of course, is salts always become aqueous. And the hydrogen's going to be a gas. Amazing. Check that out. Next, nitric acid. So HNO3, aqueous. It's nice that you guys want state symbols. Plus potassium oxide. Oh, made a mess of that. Plus K2O. That's tricky. Yeah, right. And that's a solid because it's ionic. Right, I'm going to form potassium nitrate. And so metal oxide plus acid, salt and water. I'm going to get potassium nitrate, and that is the correct formula. K plus NO3 minus. Cross and down, KNO3 plus water. Water. There we go. And now we need to balance it. So hydrogens definitely don't balance. So I'm going to need 2 hydrogens here, then the nitrates don't add, and then potassiums. Oh, that does. Oh, hello, done. Thank you very much. Thanks, chemistry. Next. So lead nitrate and potassium iodide. Ooh, and it's given you a Roman numeral. How lovely is this? This is actually, this worksheet, I did amend a little bit, but it's actually been a really nice thing. Pb2 plus NO3 minus. Crossing down, going to need 2 nitrates. So it's going to be Pb brackets NO3 close brackets 2 plus Ki. The reason why I know it's Ki is potassium is +1, I is 1 minus because it's in group 7, 1 and 1. Next, swap the metals. We're going to get lead 2 iodide. Yeah, and we're going to form KNO3, potassium nitrate. Somebody might ask, how do I know? Oh, is potassium? Oh. Yes. That one's going to be aqueous, absolutely, and that's going to be a liquid. Absolutely. Yeah, all salts are aqueous. There's only one exception to that rule. Just one. I'm going to have to give it to you now as well, because it does come up. Edexcel really like it too. Just to give you the one exception, ammonia is a gas, and hydrochloric acid. But that's not now an acid. There's no water. That's now hydrogen chloride gas. Not the same thing. You can't call it an acid because it ain't in water. And that's going to form ammonium chloride, which is a solid, an ionic solid, because there's no water for it to dissolve in. That's the only exception to that rule, folks. Right, let's balance the equation. 1 lead, 2 nitrates, 1 nitrate, double it. Right, next one. 2 potassiums, and 2 hydrogens, and 2 hydrogens. There we go. It all adds extra state symbols. Ooh, that one's cool because it's aqueous, solid, aqueous. Guys, that's really, really hard, but annoyingly. Ooh, Mr. Duncan, could you take a screenshot of the answer and post it on the Google Classroom later, please, so that nearing to the exams we can practice this again. Oh, Mel, of course I can. Absolutely. Yeah, absolutely. That's a really good idea. I think that's a grand idea. Grand. Let's see if I can new. There we go. And then I'll go save. Save as. Let's go capture. That'll do. Replace. I have no idea what I've just replaced. Lol. Cool. Right. Good question. Right now, next bit, going through these equations. Melanie, that's big brain stuff. It's Atia, I completely agree. Biggest brain. Right. So now we're dropping into some combustion practice. Okay. So we've got complete combustion of methane. So methane, CH4. Plus oxygen. Oh, it said the word complete, so we know the product, CO2 and water. And then balance it. 1 carbon, 4 hydrogens, oxygen, 2 and 2, 4, 2, and we're done. Yeah, tick. State symbols, gas, and gas. Gas. Some people might ask why the water doesn't come out as a liquid. The reason being is the complete combustion of methane. This is going to be at 900 Celsius, folks. Yeah, that ain't coming out as liquid, coming out as a gas. Definitely coming out as a gas. Next, incomplete combustion of octane. Oh, this is getting harder. Octane, so got C, oh no, gone Yorkshire. C8, H double it and add 2, 18, plus oxygen, combustion, going to form incomplete combustion. Who's my product? Carbon. Carbon particle. So you're going to get carbon solid plus water. There we go. You need state symbols. Oh, petrol's liquid. Oh, octane, liquid, gas. And then we got gas. Cool. So, okay, balance. 8 carbons. Whew, 8 carbons. 18 hydrogens. Whew, 18 hydrogens. Right, 9 oxygens. That's awkward. 4.5. Can't leave it like that. Double everybody. 2, 5, 16, and 18. Tick it if you got it right, folks. Whoop, whoop. Wait, what? Who put that? Melanie? Next. Okay, next. Incomplete combustion of propane to form a toxic gas. Propane, C3H, double it and add 2, 8 plus O2, toxic gas, carbon monoxide, water. Right, balance, 3 carbons, 8 hydrogens. You got 7. Oh, it's awkward again, isn't it? 7 need 3.5. 3.5, double everything. 2, 7, 6, 8. We're done, smashing through them. Complete combustion of butane. C4, H, double N, add 2, 8, 10. Can't do it, too slow. Next, it's complete carbon dioxide, water. Balance it, 4 carbons, 5, 8, 13, 6.5. Man, loads of doubles today. Loads of doubles. Yuck. Loads and loads of doubles. Isn't it 9? Oh no, I've gone wrong. What have I done? Oh no, what have I done? What's 9? What have I done? Isn't it Libby? Which question are you now on? Damn, you're making me doubt my questions now. So 16. Oh, 18 times 2. Looks like 36. It's a lot. 36, 18 times. It's the same thing. I like it. Oxygens. Oh, thank you. 9. Thank you, Libby. Thank you. Yeah, the octane one. Yeah. Sorry, my bad. Rushing it. I said 9 and wrote 5. Madness. Next. Complete combustion of a hexadecane. How many people had to look up hexadecane? Double it, 32, 34, plus oxygen, complete combustion. By the way, that's diesel, if anybody's interested. Yeah, that's diesel. C16, plus CO2, complete, plus oxygen, plus water. By the way, that's actually super unusual. It's diesel cars never burn it completely. They're just too long. Look how much oxygen is going to be needed. We're going to need a bucket load of oxygens. 34 divided by 2. 17? Oh my goodness. We're going to need, that's 32 oxygens plus 17 oxygens is going to be 49 in total. Divide it by 2 would be 24.5. Holy guacamole. And now we've got to double it? Oh, man, it's painful. 2, 49, 32. I don't know what that is. What's 17? It's going to be 34, isn't it? Holy mackerel. Did everyone get that? That's really hard. Wowza. That's a lot. That's a lot of oxygens. For every 2 molecules of diesel. Guys, just to get you to think about what this is saying, if you want to burn just 2 molecules of diesel, it's such a massive molecule. Just 2 of them alone require 49 oxygens? That's mental. That just shows there's just not enough oxygen in the air. That's redonkulous. That's what that is. Totally redonkulous. Next, hexadecane done. Complete combustion of propane. That becomes a bit more sensible. Who did that one? C3, double it, add 2, 6, 8, plus O2, goes to CO2 plus H2O. Balance, 3, plus 4, 6, 4, 10, 5. Done. Easy. Mr. Duncan, for question 4, isn't the number before oxygen 13? Huh? Oh, damn it! I've done it again! I didn't double it. I'm so sorry, folks. My brain's just gone, yeah, it is. I'm sorry. I'm an idiot. Just ignore me. I can't do this. If I were doubling it, I'm sorry. So out of my brain, I'm saying something and writing something different. Pretty weird. Anyway, ignore me. I'm an idiot. Next, thank you for that. Incomplete combustion of ethane to produce global dimming. Ethane, C2H, double N, 2, 6, plus O2, global dimming, carbon particulates, carbon solid, plus water. Next, 2 carbons, 6 hydrogens, oxygens, 3, 1.5, double it, 2, 3. I'm actually going to write down the right number now. 4. See what I did there? Oh, there we go. Thanks, Lara. Only one that's on the ball there. Guys, it's all just practice. I hope you found it useful to do those. It is just knowing the words. It is. I'm sorry about that. It's just a language. Right. So after all of that, I now have 25 minutes on one of the most important lessons I can ever teach you guys. Right, guys, today's title, I'm actually going to go for an entirely new sheet. We're starting moles. Wowza, moles. This is what moles is. Moles. See what I've done there, guys? It's a mole. Oh, yeah. It's a chemistry mole. So I'll get rid of that now, folks. That's just embarrassing. No, I want him back. What I'm going to do is I'm just going to pick him up. Just going to move him over here. Left behind a couple of whiskers. Don't ask me why. I don't know why the computer does that. There we go. So you can leave Moley over there. He's baby. I know he's cute, huh? I know. Keep him. Okay, he's kept. Okay, so we're doing moles today, folks. So learning objectives. Number one, I need you to understand what a mole is. What is a chemistry mole? Next, be able to use moles. Nice. Saying something different. No, I'll say moles equals grams over rams. Yeah, that was terrible rams. Yeah, grams over rams. That's, by the way, I'm gonna draw this, and I'm never ever gonna draw it again. I hate this maths over MR. I don't like it, guys. I hate triangles. I just wanted never to use that. It's disgusting. Like, you guys are beyond year 7. Like, you're going to be using moles equations that are going to have horrible people, like loads of people in it. And I do not want you to get used to using triangles. I need you to get used to not using them. So and that's all I want you to do today, folks. That's it. So the question is, what is a mole? So if we, I'm just going to put that there like that. There we go. Yeah. So moles. So number one, I'm actually going to do facts. So number one, the moles are the chemists' unit for counting particles. That's what a mole is. It's a method for chemists to count particles. Number two, 1 mole of any substance is its MR/RMM/AR/RAM. You'll get this in a minute, folks. In grams. That is one of the most useful things that I can ever give you. 1 mole of any substance is its AR, MR, REM, RMM in grams. So useful. Number 3. Now, can I just point out, there are very few times in chemistry where I get to teach a bit of history, but this is one of them. And I love this part of teaching chemistry, because having an opportunity to stand on the shoulder of giants, the scientists who made stuff up, and they did it with such beauty in chemistry. What they realized is they discovered when elements and compounds were first starting to be put together and to be broken down, they realized that they could weigh particles. Some students might ask how you do that. Well, what you do is if you take a metal and then you react it with oxygen, it will gain weight. Here, I totally agree. Oh, the guy who named it was a mole. Oh my goodness. Do you know what? That's so funny. Guys, you're going to laugh at this. Hang on. Yeah. So what they were doing is they were just simply trying to count molecules. And so they gave it the name the mole, which just means molecule, which is kind of nice. So, okay, now I go back to this. So the next thing is how many, so hang on. I think everyone here would agree that this is a fairly odd and obscure concept. We're going to count particles. Well, hang on a minute. How big is a particle? I think everyone in this room would agree that particles are tiny. So, for example, in a glass of water, in fact, in a glass of water containing I can actually give you the real number here if you like. The problem is I'm going to say 18 grams. But a glass of water with 18 grams of water, everyone agree that that's not an awful lot of water. It's like 18 centimeters cubed. Yeah, it's tiny. But in that 18 grams of water, if you were to count all of the water molecules, there are more molecules in that 18 grams than there is cups of water on the whole planet. Like if you took all the oceans, everything, and you put all of that water into glasses, there'd be way less glasses than there would be molecules in that single cup. Like particles are tiny. So how do you weigh a particle? How do you count them? And it was super clever. Because what they did was they simply said, well, hang on a minute. If helium, let's look at helium as an example. Helium has an atomic number of 2. This is the atomic number. Atomic number of 2, which is otherwise the proton number. Yeah. The mass number of helium is 4, and that's the protons and the neutrons. Well, I think everyone here would agree that there's no way that we can weigh an atom of helium. Yeah, there's no way that we can weigh this. And I like how the category of this video is entertainment. It is very entertaining. Thanks, guys. Thanks. Mr. Duncan, I'm finally back. My Mac was crashing repeatedly. I'm starting the lesson now. Amazing. Thanks, Ananya. So, I think everyone here would agree. What a ridiculous idea. It's like, I'm going to count particles. I can't count particles. And scientists knew this. They were like, they're way too small for anybody to ever count. But because we could weigh them, what we could do was a super sneaky trick. I can just say, if I measure out 4 grams of helium. If I measure out 4 grams of helium, I will have a fixed number of particles adding up to 4 grams. And then if I now do water, now water's MR, and we've already done this in our lessons in class, water is oxygen bound to 2 hydrogens, and the oxygen has a mass of 16, and both hydrogens have a mass of 1. Its total MR is 18. So would everyone agree a single particle of water weighs 18? So they just said, because we can't count them, what we will do is we will measure out 18 grams of it. And if I measure out 18 grams of water, and I measure out 4 grams of helium, I would have exactly the same number of particles, because the amount that I'm measuring out coincides with the mass number of the particle. It was genius, like mad genius, by the way, like the Hulk kind of genius. It's amazing. And this is where this comes from. That's where this lovely thing comes from. One mole of any substance is its MR in grams. So let's just do a quick game question. Question. So if I had carbon dioxide and I now wanted 1 mole of it, how much would I weigh out? Let's now do carbon dioxide. Let's now go for something else that you guys are going to see on a regular. Let's go for water again. I like that. Then let's go for, hydrogen. That's a good one. Let's then go for oxygen. And then let's go for something really stupidly complicated. Glucose. Yeah. Remember, darts. Oh no, 18. I've lost my mind. C6H12O6. There we go. So what's 1 mole of all of these things going to weigh? So all we have to do is realize that we just have to weigh the particles. So CO2, its MR is 12 plus 16 times 2. That weighs 44. So 1 mole is 44 grams. Water, which is 16 plus 1 times 2, which is 18. 1 mole will be 18 grams. Hydrogen is 1 times 2 because it's in a pair. 2 grams. Oxygen, 16 times 2, 32. We're going to have 32 grams. Glucose, 12. Sorry. Next, sorry, 12. I was checking on the chat. 12 times 6 plus 1 times 12. 1 times 12 plus 16 times 6 equals 180. Darts, all about the darts. So I need 180 grams. And I will have 1 mole of each. Now, this is super handy. At this point, I have got loads of you in the class right now who are going, why on earth are we doing that? Like, why do I care? The reason being, folks, is because we've been balancing equations. If I look at this equation, I'm going to burn hydrogen. This is my fuel. This is my oxidizer. This is my oxygen. I'm going to make just water. Yeah? And I'm going to balance it. 2 hydrogens, 2 oxygens. Right. Now, guys, this is the important bit of this. The equation says, it literally says, and I know I'm teaching a language, it says 2 particles of hydrogen react with 1 particle of oxygen. I should say molecule, by the way, but reacts with, 2 molecules react with 1 molecule of oxygen to make 2 molecules of water. How amazing is that? That's literally what it says. And so if we can count particles, we can make some amazing predictions. So I'll come back to that. Oh, I'm really tempted to do it now. I've only got 10 minutes left. Okay, I'll come back to that in a minute. So back to here. Fact number 3. Right. Sorry, folks. I'm going to try and do it to there. There we go. So underline that. Fact number 3. 1 mole contains. Now, can I just point out that this number, you will never have to learn at GCSE. They will give you it if they want you to use it. but 1 mole of any substance contains 6.022 times 10 to the 23 molecules, or particles, if you wish. Particles. That's a big number, folks. This is called Avogadro's number. And it is not the guy who came up with it. He's the guy who improved it. Do you know the guy the first scientist to work out how many particles were in a mole? Because the mole concept was invented 200 years ago. That's insane. They didn't even know how many particles were in a mole, but it didn't matter because you just gave the MR in grams. This was dead useful. The first scientist to do this, to calculate this, was Einstein. Oh, what a man. I can't spell his name. Is that Einstein? Or is that I before E? I don't know. Einstein. I don't know. Einstein. I don't know spell Einstein. How do you spell Einstein? I don't know. Anyway, somebody spell for me. Yeah. Avocado's number. Yeah. How do you spell Einstein? Can someone just put Einstein on the chat for me? I don't know. Anyway, so what that now means is, now that we've got this number, if someone said to me, someone said, I have 1 mole of water. How many particles do I have? Number of particles? Einstein. Thanks for that. Number of particles? I'm really struggling today. Particles is 6.0. 6.022 times 10 to the 23. There we go. That's how many I've got. So what would happen if I had half a mole of water? Half a mole of H2O? I'm just going to have that number divided by 2. 3.011 times 10 to the 23. I can use this to actually give the real number. Not that we ever use it. It would be a ridiculous thing to use. But really cool to be able to do that. Okay, so at this point, I need to introduce you to the equation. Okay, folks. Number of moles is grams over rams. Now, the first thing that you guys are asking is, what is that guy there? So, guys, that lowercase n means moles. It is the symbol for moles. I know, go figure. People ask me, why is it not M? The reason being is M is already taken by the physicists. They stole it from mass. So I can kind of let them off, really, because, I mean, Newton already had that. He had that a while ago. How does the chemist make guacamole? Using avocado's constant. Oh, that Mel. That is amazing. I'm going to steal that off you, Mel. And I'm going to use that from now on. It's going to be amazing. Amazing. So this is our equation. We now need to put it into practice. Just grams over rams gives us moles. So here's what I want you to do, folks. I want you to take this equation, and I now want you to have a go at these. Question number 1. I'm going to give you 10 grams of oxygen gas. Right. The question is, how many moles? Moles? Question mark? Right. Very straightforward. Number of moles is grams over rams. Therefore, number of moles is 10 grams over, what's the relative molecular mass of oxygen? 16 times 2, because it's in a pair. 32. 10 over 32, and I get a number of moles of something I don't know. No, it's not a joke. It's an actual question. Thanks. 10 over 32, and I get a number of moles of 0.3125. Not complicated. And I'll put that, the symbol doesn't go on the end. I just have to write down moles. Next, question number 2. I'm going to give you 6.3 moles of water of H2O. How many grams do I have? Grams? Question mark. Pause the video. Have a go. Show you're working. Number of moles is grams over rams. Therefore, reorganize. I'm looking for grams. Bring the rams over. Number of moles times by rams gives me grams. Insert my numbers. Therefore, number of moles is 6.3 times by the MR of water, which is 18, equals 6.3 times 18, and I get 113.4 grams. Yay! Next, question number 3. Actually, I quite like showing the rearrangement, showing that little trick. Okay, question number 3. Pause the video and have a go once you've done it. I have got 0.5 moles of X, and its relative molecular mass, it's actually relative formula mass, its RFM is, no, I'm not going to give the RFM, of X, and it weighs 50 grams. What is my MR? RFM, question mark. Pause the video, have a go. I love your jokes, folks. I just think they're amazing. Maybe ask it, why is it NA on the calculator? I have no idea. Okay, so reorganize number of moles. You should never ever learn a rearrangement. Just learn to rearrange it. So we're asking for this one now, folks. Rearrange, bring it up. Therefore, number of moles times by rams gives me grams. Then bring moles down. Therefore, rams equals grams over moles. Right, fill in your data. Grams, 50 over 0.5, relative molecular mass of 1, or relative formula mass of 100. And that was limestone. 40 plus 12 plus 16 times 3 gives me 100. Amazing. Oh no, he thinks it's a joke. Oh, it's funny. Anyway, so this equation, I just now need you guys to practice. So what I've already done is I've got a worksheet for you guys to have a go at. Now, I promise you, what I want to now do, by the way, at this point, my lesson's done. 2 minutes to spare. Right, now my lesson's done, and I'll get to show off. Right, so everyone is saying, why do I care about moles? Why do I care about moles? Yeah, why do you? Here's why. Here is the magic of chemistry. Right, here we go. Here's the magic of chemistry. Right, I'm thirsty. I want to make a drink of water, and I want to make a glass of it. Now, a can of Coca-Cola. Yeah, once you get to moles, just, yeah, the actual number, yeah, absolutely. Yep. Times by the moles times by the Avogadro's constant will give the actual number of particles, yes. I want a glass of water, which means I need 330 grams of water. Now, the problem is I'm a chemist, and I really don't want to have to go and buy it because I don't know how pure it's going to be. I want to make this stuff. I want to make my own water. So I'm going to go to the chemistry shop instead, and I am going to buy myself hydrogen gas, and I'm going to buy myself oxygen gas. The question is, how much do I need to buy? Now, the first thing I need to realize is that my equation has to be balanced. And my equation says 2 moles, this is what my equation says. 2 moles of hydrogen react with 1 mole of oxygen to form 2 moles of water. That's what that's literally, this is called a mole ratio. And that's actually why we balance equations. But here's the thing. I want 333 grams of this. So the question is, how many moles do I actually want? So number of moles is grams over rams. Right. So I want 330 grams, and water weighs 18. So I'm going to do 330 divided by 18, and that will give me 18.33 moles. Right. Well, 18.33 moles of water is how much I'm trying to make. Well, the ratio in the equation says that to make 2 moles, I need 2 moles of hydrogen. Those two numbers are the same. So if I want to make 18.33 moles, I need 18.33 moles of hydrogen. How much oxygen do I need? Well, according to the equation, I only need 1 molecule, 1 mole, to make 2 moles. So that's exactly half of what I need. So I'm going to take my answer and divide it by 2. I need 9.17 moles of oxygen. Right, how many grams are these moles? Right, number of moles is grams over rams. I want grams. Reorganize, times by rams. Right, so times that by the weight of hydrogen. Hydrogen weighs 2. So 18 times by 2, and I get 30, no, I'm going to change my color for this. 36.7 grams of hydrogen I'm going to go and buy. Now, how much oxygen am I going to buy? 9.1. This is going to be 9.17 times by 32, the mR of oxygen, times by 32, and I get 290. I'm going to have to change my color here because something magical is about to happen. 293.3 grams. Guys, what does that add up to? It adds up to 330. The magic of chemistry. It's amazing. I love it. So this is the end goal, folks. This is where I need to get to at the end of this topic. And what I'm going to do is I'm going to post on the classroom. I've already put together some questions. So look, here are your mole questions. I will post these onto the classroom, folks, just to give you a bit of practice. Yeah, just a few, only like 10. I'll post those onto the classroom now, and you can have a go. Right, I'm going to go back to my... Move it. No, put it back. That one. Hey, guys. Woo, we're done. The first lesson of moles. That's a tough one now, folks. Can I say, though, it's been amazing. Thanks so much to all of you for coming along. I think I even got Ryan, didn't I, at the end? That was amazing. Everyone came. Well done. Thank you so much, guys. I really, really appreciate it. I hope you guys are staying safe. I'll just make water. Don't forget to post the mark scheme, and thank you. You guys, you're so welcome. I love teaching you guys, and it's been nice to see you this evening. I hope you guys have a really nice rest of your night, and take care, be safe, and I'll see you next lesson. See you tomorrow, folks. Ciao.